Now, we are ready to start talking about the error codes. Errors CH21 and CH29 might be caused by a fault in the inverter's PCB or compressor. CH21 is an error in the inverter board's IPM, which may be caused by bad input power or errors in the inverter PCB itself. Bad input power consists of power source problems, fault in the noise filter, or loose connections with the inverter PCB. Compressor malfunctions can also give place to this error. For error CH29, the same reasons are valid, and also compressor's overcurrent may be related to this type of error. When error CH21 occurs, it will be displayed in the error indicator in the outdoor unit. By removing the small case on the front panel of the outdoor unit as shown, the main PCB can be identified, and the error can be seen on the 7-segment display. To determine the cause of error CH21, first, you will have to check when it occurred. Verify if it happened during compressor operation or before compressor starts to operate. To do this, first, power on the ODU. Second, connect the LGMV to the outdoor unit. And third, operate outdoor unit through indoor unit control by LGMV. Under normal operation, the ODU starts to operate and the frequency of compressor will change according to the state of the IDU. If an error occurs before compressor operation, CH21 will be displayed as shown in the LGMV. The reason is probably an input power error or an error in the inverter's PCB itself. On the other hand, if the error occurs during compressor operation as shown, it is likely that the compressor had a malfunction. For a more detailed explanation regarding this issue, please refer to the following steps. To carry out a closer inspection, start by disassembling the front panel of the outdoor unit. Then disassemble the control box cover of the outdoor unit. Their value should be 380 volts. And RN, SN, TN are the phase voltage. Their value should read 220 volts each. Check if the wires are tightly connected. Now, check the condition and wiring of the RS-TN cables. Check that the power is normally supplied to the outdoor unit, and then measure the voltage between phases. RS, RT, ST are the line voltage. If the voltage is not normal, the problem could be in the circuit breaker or in the cables. Proceed to check them as follows. Inspect the RS-TN connection from the ODU to the circuit breaker, which is located in the electric panel. RS, RT, ST are the line voltage. Their value should be 380 volts. And RN, SN, TN are the phase voltage. Their value should read 220 volts each. Then, check if the wires are tightly connected. Turn off the circuit breaker of both indoor and outdoor units before measuring the resistance. Then measure the resistance between phases of the compressor terminal. Check the resistance of the U, V, W terminal as follows. Compare the standard value with the readings for the UV, VW, WU connections. This is a megatester. It can measure the insulation resistance between the compressor piping and U, V, and W terminals. Compare the insulation resistance values for each measurement. Replace compressor if it is found defective. Now, check the terminal connections of inverter PCB. Check the U, V, W connectors are tight. If loose, tighten them. Then, check the compressor terminal assembly and reassemble it if any abnormal conditions are found. If there is not a problem with the terminals, we are then going to inspect the inverter board IPM. First, check the DC voltage, then compare it with normal voltage value. The voltage should be checked as shown in the figure and compared with the values in the normal range as shown in the table. Next, check the tightening condition of the inverter board's heatsink. If the screw is loose, you should tighten it firmly. You need to determine if the problem is in the inverter PCB or in the compressor. For this, interchange the two compressors connection and proceed to double check. Now, remove the screws connected to the compressor. Once you are done with it, interchange the connection of the compressor terminals. Get the outdoor unit running and proceed as follows. Keep in mind you need to know whether the problem is in the inverter's PCB or in the compressors. So, for example, if error CH21C1 occurs, connect the inverter PCB1 to compressor 2 and the inverter PCB2 to compressor 1 and get the outdoor unit running. After cross-connection as shown in the picture, if CH21C1 error is displayed, that means the problem is in the inverter PCB1. On the other hand, if CH21C2 error is displayed, that means that compressor 1 is damaged. Now, let's take a look at error CH29. Error CH29 deals with overcurrent in the inverter compressor, which occurs when the input current flowing through the compressor exceeds the allowed limits. CH29 occurs due to a failure in the inverter compressor caused by insulation breakdown or motor damage, low input voltage, ODU inverter board failure, a fault of the variable path valve, piping blockage, poor ODU air circulation, EEV damage, excessive refrigerant, etc. In this image, you can see error CH29, compressor overload caused by excessive high pressure. Dust particles and other contaminants may block the ODU's heat exchanger. Check every side of the heat exchanger and its surroundings to make sure it is not blocked, clogged, or has any objects interfering with the airflow. Poor air circulation at the ODU's heat exchanger may also cause this error. Next, check the outdoor unit electronic expansion valve. When you reset PCB power, the EEV opens and closes again, and if you hold the EEV valve on your hand, you should feel it vibrating. If there is no vibration, proceed to check the external PCB. After checking the external PCB, if it is okay, the EEV may be broken. On the other hand, if the external PCB has a problem, proceed to change it and check the EEV once again. Now, measure the voltage at the yellow connector in the external PCB. A normal value for the output should be 220 volts, plus minus 15%. Finally, check if the active path valve is in a normal location. These steps should solve the problem. This video was made for educational purposes. It is intended for system air conditioning engineering only. LG Electronics does not take responsibility for any problem or danger caused by general users.